AWS Cloud Path. My name is Elizabeth Adegbaju and I'll be your guide. So today we will be focusing on building an AWS web server. Just a web server, but it's on AWS anyway. So yes, we're building a web server, and I like to think of it as building a web server the hard way, because ordinarily you wouldn't be building a web server or deploying a web server in this manner, but it's essential for us to get familiar with the AWS console, know what services are available for us, how they really work, and then we can explore building it's the, let's say, the simpler or more straightforward, the best practice kind of way. Yeah. So today we'll be using the AWS 101 workshop. There's a lot of different workshop content that you have available on AWS website. Let me show you this. AWS, oh no, workshop.aws. You can check it out, and oh, this is wrong spelling. You can check it out and explore all the things that they have available there. I'm coming out. It's workshops.aws. Yes. So there's a lot of content on different domains and different levels. You see there is a level on each workshop, so you can know which ones are matching your level and which ones aren't. You can see the level 400, level 300, 100. The one we are doing today is actually level 100. It's very beginner level-ish. It's the intro. This is it, level 100. So 100 means very simple and straightforward, and that's what we're working on today. So this is the workshop, and it's going to be very detailed and explanatory. I haven't implemented it myself. I mean, I have deployed web servers, but not through this very click ops-ish way, like clicking through the console. And yes, I would like us to work through it together, and I'll be explaining things as I go, and breaking down like things that may be more complex or simple instructions that you may want to know the why behind them. Yes. They said it takes 1 to 2 hours to complete. I hope we can achieve it in less than an hour, even with all the explanations that we're adding to it. It's not totally free because we'll be deploying some instances. So if you're going to try it yourself, I'm sure you would have seen this, but let me make it bigger so that you can see everything that I'm saying here. Yeah. But it's really negligible, less than 50 cents, and I'm thinking that you should also be able to run some without incurring costs in a new account. But yes, just make sure to check with that before you get started. And yes, let's go. So the first thing we have here is the architecture of this project that we're going to build. I am guessing you may have seen images like this, and if you are interested in architecture, you're familiar with it. And if you aren't, then you haven't tried to make sense of all the icons and everything you see there. I'll try to make it quick. But it's very important for you to understand the architecture of whatever it is you're trying to build. It will save you a lot of headaches, and also some troubleshootings that you'll be doing would be very, very clear, like from the beginning. All these boxes and squares and rectangles, they have meanings, and it's important to put the right thing in the right place. If not, you'll be looking for it when you want to connect something to it. So I'm going to start with the what they call this outermost shell, which is the one that has AWS logo at the corner there. Every of the boxes or the rectangles or squares that you may see, they are labeled. There's a labeling, and when you go deeper into AWS architecture, it even gets easier because you understand the color coding, the kind of what do you call this? The kind of lines that are there. You understand it at a glance what this means or what this color or this icon stands for. But without further ado, let's get started with this one. So here in this thing, I'm coming. I want to get my, yes, I'm gonna get my, yes. So I don't know if you can see what I am writing or not. Okay, let me just clear it and get started again so that yes. So here, this outermost shell is the AWS environment. That is, just think of it like AWS worldwide, and you can look at it like your AWS account, like whatever it's just the free AWS space where everything, all the resources that are in AWS that you have access to are staying. And within them, they are usually classified even further by region, by zones. If you were with us last week, you would have seen we talked about the AWS global infrastructure, and this is a good example of deploying your applications like with good knowledge of the AWS global infrastructure. So here we have one region, that's this one. You can see we have the outermost shell encasing this blue, or is it teal, yes, with the dashed square, dashed rectangle actually, and it has a flag. That's the region that we are deploying all our services in. We are deploying everything in the same region because, I mean, that's what makes sense. If you want to go like maybe higher availability, you can do multi-region deployments, but that's like deploying a whole setup in one region and also making a copy of that same kind of setup in another region so that it will be available if one region goes down. But we don't need that level of availability here. And within our region, we have two availability zones. You can see availability zone 1, and we have another availability zone here. The availability zones, like I said, they're like a cluster of servers or resources inside a region. If an availability zone goes down within a region, the other availability zone is still available, except if something happens to the entire region. I'm talking about the physical locations now in AWS, data centers and all that. One availability zone has the resources in one location together. So in AZ1, I'll be saying AZ to represent availability zone. In AZ1 here, we have resources deployed, and then in AZ2, we also have resources deployed there separately. And this is a form of high availability, or you can say redundancy, whichever one, but it's just making sure we have a higher level of availability for our setup, for our environment, so that it wouldn't all go down once and for all. It wouldn't all go down once and for all. So in each availability zone, we have one public subnet and one private subnet. And subnets like encapsulates like resources in its own subnetwork. I think that's the best way to put it. Like when you are defining a subnet, you have to define, okay, these are the IP addresses that are going to be available to assign to resources inside this network and all that. So you can have multiple subnets inside one VPC. You can have subnets in this availability zone, subnets in that availability zone, all of that. You can have that inside one VPC. I think if you don't understand any of the services or any of the resources or any of the terminologies that I'm mentioning, you can always drop it in the comment, or you can just Google it, look it up. AWS has like very, 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 very robust documentation on everything. And also, it would still be touched on as we go in the actual development of the servers and everything. Every single thing we're using here would be elaborated, and you see how they really work. But I'm trying to explain why it's all looking like this. So we have this separation in the networks. This virtual private cloud that you see, this one here that is color purple, can you see it? This one, it is the it's like a basically it's a virtual private cloud. That one, when you're defining it, you define the networks, the subnets that are available inside the virtual private cloud, or the IP addresses, or the basically isolating resources separately. So you can have multiple VPCs inside your environment, and for any resource in one VPC to be able to communicate with another VPC, you have to explicitly define the connection between them, which we won't be going into, but there are different ways you can connect VPCs. But the point is, it isolates your resources, it isolates whatever you are deploying within AWS. Now, all this isolation, all this security, everything we're talking about, we need some way to make them work. Your VPC has two endpoints here that you can see, or let me not say endpoints. You can see the this one, the VPC endpoints. What this is that it's a way for you to connect resources in AWS environment with your own resources. Like Amazon S3, for instance, it's not you that owns Amazon S3 in your private account, but you are able to, send resources to and from S3 without having to go through the public internet space. So when you configure VPC endpoints for your resources, then you are able to communicate with them directly without going to the public internet. So what you every resource that has that let's say that feature or that function, you have to configure like VPC endpoint for S3, VPC endpoint for this, VPC endpoint for that. So Internet Gateway, on the other hand, is exactly what it does. It's what it says. It gives access to the internet. You can see this internet cloud here, and then there's the internet gateway that is connecting to. But you can also see two other arrows from here and from here that are able to connect to the internet. Please take note of the direction of the arrows. It's very important. The internet is only able to come into your environment through the internet gateway, but it's not able to, this other arrows that you're seeing is not able to come into your environment through those arrows. It's only coming out to the internet. Connections are only coming out to the internet. So yeah, we'll be looking at that. So there's the public subnet, there's the private subnet, and they're exactly what they say, public and private. Public means it can communicate with the external world, with the internet. Private means it cannot communicate with the internet directly. So it's communicating through the public subnet, and there's a NAT gateway that is deployed there such that it grants access to the outside world, but not access back in. The direction of the arrows matter. Every time you're looking at your architecture and all that, pay attention to all the little details. The subnets, all the CIDR block, that's the IP address ranges that are written there, they're all important because you don't want them overlapping, you don't want this. So always pay very close attention to whatever architecture that you're working with. A lot of times you're working with people and you see that the questions that they come back asking, or the questions that they are lost on, are actually already very clear in the architecture if they just went back to look at it one more time. So yes, we have that. And you see our web server is deployed inside the private subnet. We also see that we have an application load balancer that is deployed here to balance the load across the web servers. I see that we only have one web server, but I mean, we'll get to see what we're actually building in the end. But application load balancer is also a way to expose your private servers, because you don't want them, they don't have public addresses that you give to the internet people to connect, like all your users. But when you connect your application load balancer to your private server, because that's in AWS environment, and they are able to connect to your load balancer, and your load balancer would connect to the server. Nobody's connecting to your server directly like that. So you see the application load balancer is inside a security group, and the web server is also inside a security group with the same colors that they are. I see that this is red, and this is also red. They're security groups basically. And what this does is it limits who can access the resource that is inside the security group. All the resources that are inside the same security group can connect easily with each other, but you can restrict, okay, if I want this other security group resources to be able to connect with this one, you grant access to it. That's what I see with this arrow. You've granted access to the web server, and then the web server is able to communicate to the S3 here through the VPC endpoint and all that. So all the connections, all the networking, everything has been planned out well here, if you ask me. The web server has its way to connect to the internet. The internet has its way to connect to the web server. That's through the internet gateway and the application load balancer. And the web server also has its way to connect to S3 through the VPC endpoints. And all of this is well planned out, and now we need to implement it in the AWS environment. So I think we can move on now. Let me clear all of this. But yeah, I think we can move on now with where we are. Okay, I think this is much better. So yes, I was talking about deploying this and all the steps that we're going through to deploy everything here. The first thing is to set up our VPC, and I came to the VPC page, searching through the VPC here in the search bar, and then you come to the home page. You can create VPC here, and you start with a default setting. If you put VPC and more, you have all the extra things that we need to set up already kind of in progress here. Whereas if you have just VPC only, it's only that outer shell, not the subnets, not the route tables that define how the subnets should route like or the network, or not the internet gateway or the VPC endpoint for S3 that comes by default. Everything you can get it in VPC and more. So this is the preview of everything that is going to be set up by default with this kind of setup. This is the preview. You have the subnets, 4 of them. You can see there are 2 different availability zones here. The region is EU Central 1, and A says availability zone A and availability zone B, basically EU Central 1B availability zone. And for each of them, you have the public. You can check the names. You will see everything in the setup here, basically. But when you look at this, you see that a lot of things are already created for us from our architecture diagram. So this is the internet gateway. IGW is the internet gateway that grants like external internet access into the environment, into the VPC environment. And this VPC endpoints S3, like I mentioned, is the connection from our VPC, from our isolated virtual private cloud, to the S3 service without traversing the internet. So this is going to be securely within AWS connections, not going through the internet to transfer files or to get files. No, it's not doing that. So yes, this is the default setup that we have here, and we're going to be scrolling down. From our guide here, it's been told to us that when we are creating, we should create VPC and more, and we will see our review. Then we go ahead and explore all the connections that we're going to be creating. The next thing for us to do would be to create our NAT gateways. There are things that would not be automatically, or that they are not by default in the VPC package that you get with the VPC and more. Things like NAT gateways, your security groups, configurations, and all that. You need to set that up by yourself. Yes. So here we have NAT gateways. Create 1 in each availability zone. You see it here in bold, 1 per AZ. So we're going here to our NAT gateway. Our NAT gateway is down here, and we're going to click 1 per AZ. So going through everything, you can explore all the different settings that are here, but basically by the default one is okay for this particular deployment. You can change it up. Here you can say maybe you want up to 3 availability zones instead of 2. We have 2 availability zones in our architecture diagram. And if you only want 1 availability zone, which is just one deployment setup, that also works fine. And then the number of public subnets is 2. The number of private subnets is 2. 1 subnet in each availability zone, 1 public subnet in each availability zone, and 1 private subnet in each availability zone. Don't be deceived that, if you have 1 private subnet here, you have 1 public subnet there, you use it together. It doesn't work like that. So you just want to have a copy, a replica of that particular setup that you have here in the other availability zone. We're making it highly available, basically. If this one goes down, the other one is still running. And here we have NAT gateway. We've selected 1 per AZ. We want 1 in each availability zone. And our VPC endpoints is S3 gateway. We want it. You can say none if you don't plan to have a VPC endpoint for S3. You can say none, but our architecture requires it, and we're going to work with that. And after we are done with that, we can create our VPC and we can move on to the next resource. So we'll come back and answer these questions, but let's create our VPC first. You can see all the different resources that it's creating. This is why you should be very careful with AWS, because it looked like, I just opened VPC and I clicked 1 button at the end and it's deploying like 20 resources in my environment, some of which would cost money, yeah? But we'll come back to this. So now we're going to be looking at security groups. Remember, I said that when you are working with the VPC, it's, even though there's a whole VPC package that you have coming by default, you won't have every single thing set up for you from the beginning. You may need to change your arrangements in your VPC, and definitely you need to configure your security groups by yourself. So security groups are essential for security in the AWS environment. All the resources that you are doing, all the resources that you are deploying should be deployed in a security group. And the security group, you would now have your rules configured for that security group. Rules on what can get into that security group, what kind of requests, what kind of connections can go into that security group. And that restricts, it's another layer of security that prevents external attacks or stuff like that from getting in, because you've already predefined who and what can get access to the security group and on what terms. I'm talking on what terms, you're talking which kind of protocol, on what ports, on all those kind of things are configured in your security group. And I also like to remember, or I remember and I like to remind people that security groups are also like one of the easiest ways to quickly respond in an attack to. Like, you have this security group that is already predefined and is closed off from any external influence, and then you see like weird behavior and you quickly change the security group of your server so it is suddenly closed off from external connections because you have moved it to another security group that no external connection will be able to get into it from. Like, there are different, I won't say different reasons, because security group is used for one thing, but it's important for a variety of reasons. Yes. So now we are going to be working with our security groups. Security group is part of EC2 instances, EC2 services, and the EC2. Here you can see it's Amazon EC2. This EC2 is the equation of instances, servers in AWS environment. It's the equivalent of servers in the AWS environment, I would say. It's not equation, because you might see a lot of names and you wonder, okay, what is this and why is it named that? Well, yeah, you have it. Elastic Compute. I'm coming. Let me open EC2 here for you. Okay, our VPC is successfully created. We can view it and then continue. So this is what it looks like. We didn't change the name. This was what it automatically generated for us. Project VPC. And this is our VPC ID. It's here. You don't need to cram it. It's always here. You can use it for other kinds of setup. But it's always there. We're going for our EC2. Yes. So virtual servers in the cloud. Virtual servers in the cloud. That's what the EC2 instances are. We have 0 instances running right now. 0 instances running. So this EC2 that we always talk about is actually, if you ask me, I'll say it's EC squared. It's meant to be like C to the power of 2, because if I remember correctly, is Elastic Compute Cloud or something like there are 2 C's there, and then they said EC2 about. That aside, let's continue. So we're deploying our servers, and here we are going to firstly create the security groups that we want to associate all these things with. Remember our architecture here, bringing it up for reference again. So far what we have created our availability zones in this region with our subnets. Like we did all of that with our VPC setup. This purple VPC you can see here. So we already defined everything that we want to create. These 4 subnets inside these 2 availability zones in this region. So we've already deployed like more than half of our setup with the NAT gateways. And now what we want to set up is our application load balancer, our web server, and connect everything well together to work together. So our web server and our application load balancer are in a security group. And they are in security groups, and we need to define that also. It's in EC2 instance. In your sidebar, you would be able to find the security group here under network and security. So we're going to security groups. Oh yes, we have default security groups. Default security groups. Let's look at it here. You can see there are in 2 VPCs. You see security group in the default VPC security group, and then there's another default security group in default VPC. You'll be wondering why we have 2 default security groups, and when I showed you here, I told you there are 2 VPCs here. 2 VPCs. We created only one, right? There is a default VPC that comes with your AWS account when you open it. If I open VPC now, you see there are meant to be 2, I believe. There's one that is default, and then we created this one that we wanted with the configurations that we wanted. Here we can have a look at it quickly before we continue. VPC, fingers crossed, there should be 2. Yeah, there are 2. There are 2. You can see 2 VPCs. You see this one that has no name is the default one that was created, and this is the one that we have with our project VPC. For you to be safe, normally try to create a different VPC whenever you are doing whatever in your environment, because there's a lot of restrictions with this default VPC. For instance, you cannot use it with VPC peering and all of that because of the CIDR range, this IP address ranges. It gives you a lot of restrictions on what you can use it with. But basically, we have 2 VPCs, and this is the one we are using, our project VPC. Take note of that so you don't mistakenly use the wrong resources when you are connecting things. Yes. So now, going back to our building website, we are in security groups, and we're going to be setting this up. So here, security groups, we have default security groups that are there, but we're going to create our own security group. Let's go back to security groups in our EC2. Security groups in the EC2 feature. I'm going to create security group here. There are no rules yet in our security group. Everything is default. Let's see what we're meant to set up for our environment. We have to set the settings as they want it to be. So the name of our security group is going to be Load Balancer Security Group. I believe this is the one for our load balancer. Remember, we have 2 security groups we're going to be setting up. The description is external access. This makes it very easy for us to work with. And we are going with the VPC that is our project VPC. So we have to make sure we select this one that is the project VPC. And the inbound rules, let's check what inbound rules we have here. So in the inbound rules, we're going to add a new rule, and this is the entry. Remember I said that you're the one that's going to define exactly what can gain access to the resources in your security group. So instead of having to set this rule or this restriction per resource for every resource, you can just attach it to a security group, and then these resources that you want to have the same kind of restriction and all that, you put them in the same security group, and then you can just handle the security group directly. Here, this is what we're going to be working with. HTTP on port 80. HTTP is always port 80, and then the source is from anywhere. This is totally open. It's not very safe, you get. But for the source, you could restrict it to particular IP addresses. You can restrict it to another security group in AWS instance, in AWS environment, and all that. So it's really flexible for you to define. And we're going to work with that. The type we have here, it should be HTTP. We have it here. And then you see we're not able to exit it. This is what I said, like HTTP is always port 80. These things are by default, the protocol and the port range. And the destination, no, well, okay, no, this is not. I made a mistake here. I was tampering with the outbound rules, but I'm just going to leave it as it was, because here we had anywhere, or rather it was, I think, this security group. Let me just open it again. Yeah. I'll paste this all over. But don't make the mistake I made. I was tampering with the outbound rule instead of the inbound rule. It doesn't really make a lot of difference, actually. I'll explain why. But outbound rules, you can see it allows all traffic to go out. It's totally unrestricted. But the inbound rules is the one that is important for security groups, because with security groups, all traffic is allowed out by default, but only what you allow in comes in, and it remembers its way out. So even if I remove this outbound rule, I delete it or whatever, by default in security groups, they are what we call stateful. Security groups are stateful. It remembers its request, and whatever goes out is allowed to come in. It's whatever goes out is allowed to come in. And then this inbound rule is what we are setting up right now with HTTP 80 from anywhere, and where you have this description. So let's go. We add a rule for HTTP port 80 from anywhere IPv4, and then we set this. And that's all for this rule. Yeah. Do we have another rule? I think not. We don't have any other rule. We have only one. And we can add tags to it. So tagging your AWS resources is not a requirement, but it just makes life easy for you when you're starting to track your costs and track whatever project you're working on, and separating them. Okay, this project is for this, this resource is for this project, this resource is for that project. That's what tags really are for. They're not useful for the actual resource itself. It's for your own self and your own processes. So our new tag, we're going to add the name, and it's basically free for you to put anything you want to put. It's your, and that would be all. We need to create another security group also after this. So we create this one, it's there, and we would create a new one. So this one is a load balancer security group, and this is our security group ID. We also have VPC ID. We have IDs for almost everything. And we're going to go back to security groups, and we'll create another one the same way we created this. So the name is going to be web server security group, and the description is going to be web server access. We're putting that here, And the VPC is going to be our product VPC as expected. And these inbound rules, from our architecture, if you remember what we were looking at, only the load balancer security group was able to communicate to our web server security group. Let's confirm if that's the rule that we have here. Yes. So you can see we have HTTP port 80 from the load balancer security group. And the description says to allow HTTP only from the load balancer. Comparing this with the other setup we had here, the source for our load balancer was from anywhere, like from 0.0.0, from anywhere. And here we have from load balancer security group. So two we're going to be working with. And I'll also show you something when we're working now. You will see that when I select this HTTP and the source custom, I'm able to come in. Oh no, this was not. This is what I'm putting in the description. But I want to copy the load balancer security group. Should be able to search it here and select it from, because we created it first. So the order we created this also matters. We wouldn't be able to select load balancer security group here if we're trying to create this one first. That can be an issue if you're trying to do things out of order in your environment. Sometimes that is the source of the errors people are running into. When you're even using code programmatically to create these things, not putting the right dependencies, like, okay, create this one first before you create the next one, can cause you a lot of issues. So here we have the load balancer security group, and that is all except our tag. We need to add the tag here. Name web server security group, and that's all for us. You see, we're done with our security groups. Yes, and create security group. That's all. So we have two security groups that we have created. There are other two that we didn't create, but I mean, with our VPCs here, you'll be able to see this one's in our VPC. So web server security group and load balancer security group ready to go, and we can move on. And next would be IAM management. So we have IAM management, we're familiar with it. We set up a user in the first lesson that we had, first episode, like 2 weeks ago actually. And today we're actually not going to be setting up a user, but I believe we'll be setting up a role. So when we looked at it the other day, I tried to show like some different entities we have here. Yes, this is a dev user that does not have access to all these IAM things. But here you can see user groups, users, roles, policies. Like there are different like resources that you can create, like policies, and attach it to a role, or attach the policy to a user, or there are pre-made policies that exist in the environments that you can attach to a role. So basically all of this is, I can create roles. And AWS, what are we back here? So this is how our web server is going to be communicating. When you are deploying a server, you want it to have its own instance profile. You don't want to be using the same way in your CLI, where we configured it, that you put in your AWS secret key, AWS access key, all of that. No, you want to actually attach a role to that server, so that when it wants to perform instructions, or when it wants to do anything in the AWS environment, it would only work with that role. It will assume that role and work with it based on the permissions you have given that role automatically. So yes, that's what we're going to be doing now. We're going to be setting up the IAM role, and that will be here. We're going to select roles, we're going to create the role, and we're going to attach policies to that role. So let's get started with that. Here we're going to create a role, and this role is for an AWS service. Remember I said there are different kind of entities. So this is AWS service that I'm creating this role for, and that is EC2. We are creating for EC2. Let me see the exact thing that we're following here. EC2 for the use case, and then we're saying EC2 role for AWS Systems Manager. There are different use cases that were listed that we saw just now. We don't need to dive into them, but basically what we are doing here is just giving it access so that it can call like very simple services that AWS Systems Manager needs to work with the instance on. So we're going to be picking EC2 role for AWS Systems Manager, and we're going next. Yes, I mentioned that this user does not have sufficient access, but I guess we can quickly get that sorted. If I will log in to the root user, and then I am going to do that. Now I'm going to add console, sign into a new session with my root user email. So it was essentially the restrictions that I had placed on that particular user. It only has access to perform commands in the console, but not access to create users, to view views and all that. So we're going to follow the same thing, creating a role here, and I'm going to use AWS service for EC2, and I'm going to select EC2 role for AWS Systems Manager, the same way we did in the former one. So next, and the policies, I think this is all. I'm not sure we need one. Let's check here to confirm. It's only the SSM manage instance core policy that we need to add, and we are going to name the instance, the role, this web server instance profile. That's the name of the role. We're going to add it, and we're going to create the role, and that will be all for us here. So next, I add the name of the role, and I'm creating it. So yes, I've created this role here, and that's all for our IAM setup. So this EC2 deployment, I will deploy it here. It's not much actually. What we need to do is to go to the EC2 service. So everything we are doing is still within our architecture setup. I just want to make sure we deploy everything here before we go. We've set up most of it already. The regions, availability zones with the private cloud, our VPC, with our NAT gateways, our public subnets, and the internet gateways. Everything here is mostly set up, NAT gateway. The point we are at now is our web server and our application load balancer. These two, we've not yet deployed them. Everything else is already deployed with our security group existing and all of that. So now we are going to be deploying our web server. And here we have coming. Yeah, so this is our root user. You can see it here, and I don't want us to continue using our root user. So I'm going to be switching to the dev user, which we have here. Remember I said I don't do things with the root user account. So this is the dev user that we're going to be using. We're going to EC2. here we have deploy the compute. So we want to deploy our servers into the AWS environment. We've set up the environment we want to deploy it in. We just need to mention, okay, put it in this particular security group, in this particular VPC, everything else we've created, put it there. We've gone to EC2 instance. We're going to launch the instance and we're going to name it my web server. So here, 0 instance running. We're going to come here, launch instance, and we're going to name it my web server. As I said, scrolling down, you get to select what kind of operating system that it gets to have and the size of all this. Yeah, basically configuring what options you want. We're selecting Amazon Linux 2023, Amazon Machine Image, and 64-bit architecture, and that's what we have by default, so we just scroll past it. The next thing would be the instance type. We're meant to have t2.micro instance type. So there's a whole documentation on the EC2 instance family and the different EC2 instance types, their size, their speed, and all of that. You can look at it if you want to. Just Google EC2 instance family, you will get that, or EC2 instance type. I think documentation should also come out. And I said this because it's important for you to know what you are getting into. These instance types are not the same price. All of them are different in price. They are different in size. Not all of them are free tier eligible. Some of them are not. So just know what you are deploying anytime you want to deploy EC2 instance. Check it out. We selected the EC2 instance type, and this is the default setup for this instance type. We have normally SSH keys, but in this case we are using systems manager to connect, so normally you don't use SSH with systems manager. SSH is giving access from your external machine to connect to the EC2 instance, so you have to expose the port you want to connect on and all of that. But with AWS Systems Manager we don't need to do that. That's why we configured AWS Systems Manager role on the EC2 instance. We are proceeding without a key pair. And proceed without a key pair. The reason why it says not recommended is not because you need to use SSH. It's saying not recommended because once you launch the instance without creating a key pair from the beginning, you won't be able to create a key pair again. You would have to create a totally different instance to have a key pair. Like, basically, once you create it, this is something you cannot change anymore. So if you are creating the instance, it's better to create the key pair even if you don't plan to use it with SSH and all that. But once you create the instance without the key pair, you won't be able to add the key pair, at least if I remember correctly. Yeah. So in network settings, click edit and we'll configure it to use the private subnet that we have set up. That's what we're going to be doing. It's going to be in, let's see, edit this network settings. We're putting it in our product VPC, remember, and we're using not the public. You see it's selected public. We're putting it in the private subnet. Make sure that's clear. And private subnet 1, that's what we picked. What else do we need to configure? Firewall, that's the security group. So we're going to select our security group that we have created, and then we can move on. So we select an existing security group. You can also create a security group from here, but I mean, we already created it. So we'll click the web server security group. Remember, that's the one that we're putting our web server in. This advanced network configuration, there's not much we need to do here. I believe everything is already. Oh yeah, the instance profile we created. So here we have our instance profile. Sorry. Here. Advanced details. Instance profile. So I can write the instance profile there. I'll copy it because I have access to this other one. I just need to open the EU Central, just where we are. And I'm going to the rows because I need the detail of this row. Normally you should be able to select it there, but because I restricted the access of this user, I'm not using the root user, I'm not able to see every single row there. So I'm going to copy this ARN, and that's what I'm going to put there. I have to write the full name. Well, maybe I just copy the name instead. But it should work. Yeah. So I put the name of the instance profile here, and I think that is all that we needed to update in the advanced details. And yes, the user data. So whenever you're deploying your EC2 instance, anything that you want it to do, like while initializing or like at the beginning, you can put it in your user data. So anything you put here is run on boot. Anything you put here is run on boot. So you want it to set up some things, install this, install that, get the web page, fetch something from GitHub, all of that. You can put it in a script here and put it there. So that's what I'm going to be copying and putting there. This essentially, it installs the session manager agent. That's the SSM agent. And it installs and starts a PHP web server. It goes through all this systemctl, starts HTTPD. If you know HTTPD, you know it's a web server too, like Apache. And install the SDK for PHP, that AWS SDK for the code thing. You install web pages and it updates it. It's basically setting up a web server in this setup. I'm going to put it in the user data. So let me close everything so that we can see clearly what we have here. So in advanced detail, user data, I think should be somewhere here. Yes, in user data. So you just come and paste it here. You can also upload a file from your system if you have what you want to upload, and that makes it very easy. I believe at this point now we should be able to launch our instance. Yes, once we launch it, it would spin the instance up and it would let us know when it is completed. I am not able to assign a role to a user. I created this user with power user access. I think at this point it's best for me to just give I'll give our user an additional permission. Currently it has power user access, yeah, but for now I'll put let me add permission, attach policies directly. Let's see what we have here. I want to give IAM full access. So I want that user to be able to manage the roles and all that. So I'm giving IAM full access to add permissions, and this user should have that. Yep. So I'm going back here to our launch instance, and I'm going to retry failed tasks. It worked. So all the restrictions around IAM is solved once and for all. We shouldn't be encountering that again down the line. And that's the way to solve it if you want to. But essentially, you don't want to just grant IAM full access to anyone. But because this user is going to be trying and learning a lot of different things, including IAM, so I think it's best to grant that access. And here we have launched, everything passed, and we can go. Our checks too. Yes, 2 of our checks. Let me see instances. I should have running. Let me pick it. Let me check it here. Status and alarms. Let's check it here. It's still checking the status checks, the instance status checks and the system status checks. But when we come back here, we should see everything passed, because we didn't do anything special in our environment. And there we have it. We have fully deployed our EC2 instance. Now we are well over our time. I would like to apologize because I took extra 18 minutes, because for a period during the session, actually my screen wasn't showing as expected. I got feedback in the chat, and I had to take some time to go back to recover the parts that had already passed. So we'll be continuing next week. We will learn how to go into our web server and check things there, to run things in our web server, to basically work with it. And we'll deploy our load balancer, we'll test the web server, configure the storage connection, and then the auto scaling group. Remember, I said originally in our architecture, I see only one instance here, and we're using an application load balancer. At the end, we would be configuring our auto scaling group ourselves. It's not there in the architecture, but we'll learn how to do it together. So we've successfully reached 50%. If you ask me, I'll say more than 50%, because from here we already have almost all of the architecture deployed, except the load balancer, and we've not yet connected to S3, but everything else is deployed. So yeah, good job. Thanks for staying with us today. Look at it, our EC2 instance here. We should have it running fine before we go. We have to see that status check green before we go. Yes, 2/2 checks passed. Thank you for staying with me today. I wish you a nice day, or rather a nice night if you're in the night like me. Bye bye.